everyone, today I'm going to talk to you about two-step equations. So two-step equations just means that we're solving for a variable, solving for a letter with two operations, or two steps. So when we solve two-step and multi-step, we want to reverse our order of operations. So when we simplify expressions, we use PEMDAS, or our order of operations. But when we solve, because we're kind of going backwards, it's like we're undoing the simplifying, we're trying to figure out what it looked like before, we want to reverse that. So we're going to do subtraction or addition first, then I guess I'll write it completely backwards, then division or multiplication. But remember, subtraction and addition and multiplication and subtraction and addition and division and multiplication kind of go hand in hand. And then we would do exponents and then parentheses. But really for our purposes, we're going to look more so at subtraction and addition first and then division and multiplication. Subtraction and addition first, division and multiplication second. That's what we want to do. So for number one here, when we want to get x by itself, when we want to isolate x, when we want to solve for x, we want to add or subtract away first. So I have 2x plus 3, so I'm going to do the opposite or the inverse of that. I'm going to subtract 3, and whatever I do to one side of my equal sign, I must do to the other for my equation to stay balanced. So I'm left with 2x, negative 3 and positive 3 cancel each other out, equals 9 minus 3 is 6. Now I have 2x, and remember 2 is our coefficient and x is our variable. When those two things are together like that, it's multiplication or multiplying, so 2 times x. The opposite of that is going to be division, so I'm going to divide by 2, and so x is equal to 3. For number 2, I want to add or subtract away first. So what's being added or subtracted to x is that 3 minus 2 times x is equal to 9. So I want to add or subtract away that 3 first. It's like the furthest thing that's attached to x. So right now it's a positive 3, so I'm going to subtract it in order to zero it out or get rid of it. And remember, I'm not really getting rid of that 3. I'm just rearranging the look of this equation to solve for x. So as long as I'm doing minus 3 on the left side, I have to do minus 3 on the right side for everything to stay balanced. I'm just manipulating the look of the equation. 3 minus 3 cancels those out or zeroes them out, and we're left with negative 2x is equal to 9 minus 3 is 6. Now I have negative 2, and we definitely want to keep that negative there. Negative 2x, I want to isolate x, so I need to divide by negative 2. Negative 2 divided by negative 2 is 1x, 1 positive x, and 6 divided by negative 2 is negative 3. For number 3 here, 4 times x minus 5 equals 11. I want to add or subtract away first. So I have minus 5. I want to do the opposite of that, so I'm going to add 5 to both sides. I'm left with 4 times x, negative 5 plus 5 zeroes that out, and 11 plus 5 is 16. 4 is my coefficient, x is my variable. When they are attached like that, it's multiplication. The opposite of multiplying by 4 is dividing by 4. 4 divided by 4 is 1x equals 16 divided by 4 is 4. I'll move this one over. There we go. So for number 4 here, we have negative 10 times x plus 6 equals 76. I want to add or subtract away first. So I'm going to subtract 6 to start to get x by itself. Negative 10x equals 76 minus 6 is 70. Negative 10 times x, I want to do the opposite of that, so I'm going to divide by negative 10. I want to do the opposite of multiply. Negative 10 divided by negative 10 is a positive 1x equals 70 divided by negative 10 is negative 7. Number 5, when we have x in the numerator and 2 in the denominator like that, we have x divided by 2 minus 4 equals 8. I still want to add or subtract away first, so the opposite of subtracting away that 4 is going to be adding 4. Adding 4. X over 2, or x divided by 2, is equal to 8 plus 4 is 12. So since I have x divided by 2, I want to multiply by 2. And multiplying by 2 can also look like multiplying by 2 over 1. 2 times x is 2x. 1 times 2 is 2. So that really cancels those out. 2 divided by 2 is 1. So I'm just left with x here. Since I'm doing the inverse operation, I should just end up with 1x. And 12 times 2 or 12 times 2 over 1, either way, is 24 or 24 over 1. And so that's what x is equal to. Number 6, x divided by 3 plus 6 equals 18. I want to add or subtract away first, so I'm going to subtract 6. X divided by 3 is equal to 12. Divided by 3, the opposite of that is multiplying by 3. I know if I do the opposite, I should cancel those numbers out, so I'm just left with 1x. And I can also cross cancel. If I have 3 in the numerator and 3 in the denominator, those cancel each other out. And there's just 1x there. X equals 12 times 3 is 36. Number 7. X plus 9 divided by 3 equals 8. So I want to add or subtract away first, but here there's nothing to add or subtract away without needing to get rid of that dividing by 3 first. So when x plus 9, when you have multiple things, when we have a binomial here, we have 2 terms in the numerator, there's like an invisible set of parentheses here, so parentheses are actually going to come last. When we solve, we have addition and subtraction first, multiplication and division second, exponents third, and parentheses last or fourth. So because x plus 9 is all in the numerator, all of that has a bar underneath it, x plus 9 is a package deal for now. So I need to put those in parentheses. So first thing I really want to do is multiply or divide away. I'm going to multiply by 3. And that cross cancels, so I'm just left with x plus 9. 8 times 3 is 24. Now I can add and subtract away. So now, even though x plus 9 kind of came as a package deal first, now that's all that's left is that plus 9, so I don't really need those parentheses anymore because I'm going to get rid of the 9 by subtracting it away. The parentheses are just for the package deal of making sure I'm dividing first. So 24 minus 9, well, 24 minus 10 would be 14, but I'm not subtracting 10, I'm subtracting 9, so I've got 15 here. The next one, number 8, only x is in the numerator, so I have no parentheses here. X is already by itself in the numerator. So like before, I'm going to add or subtract away first. Negative 11, the inverse or opposite of that is plus 11 or positive 11. So I'm going to add 11 to both sides of my equal sign. Negative 9 plus 11, those are opposite signs, so I want to treat them like subtraction. 11 minus 9 is 2. And our answer is positive because 11 is the greater absolute value. And 11 is positive. Now I'm left with x divided by 8. Opposite of dividing is multiplying. 8 times 2 is 16, and I'm just left with 1x over here. Now, if I have 16 is equal to x, I can also write x is equal to 16 by the symmetric property of equality. Doesn't matter whether the number or the variable is on the left or the right side. Doesn't matter. As long as I have one x left equaling one number. Number 9. X divided by 4 plus 6 equals 9. X is already by itself in the numerator, so there are no parentheses here. We just have x, so we can subtract away 6 to start. X divided by 4 is equal to 9 minus 6 is 3. Opposite of dividing by 4 is multiplying by 4. X is equal to 12. Number 10. Number 10, I have parentheses here. I didn't have to make them. They were already given to me, so I know that x plus 5 is coming as a package deal. So I don't want to subtract away first. X plus 5 is together to start. So if I can't add or subtract away for anything yet, I want to try multiplying or dividing. So when I have 2 next to those parentheses, that is another indicator of multiplication. So right now I have 2 times the package of x plus 5. So I want to divide by 2. Divide by 2. 2 over 2 is just 1, so now I just have x plus 5 equals negative 2 divided by positive 2 is negative 1. I could keep x plus 5 in parentheses if I really wanted to, but I shed them because now I only have x plus 5. I only have what was in those parentheses. So that is the only package that's left. And I want to get x by itself. So adding 5, the opposite of that is subtracting 5. X equals negative 1 minus 5 is negative 6. When they have the same sign like that, we want to add them and just slap that same sign on there. 1 and 5 is 6, and they're both negative. If I start on my number line at negative 1, and I subtract away 5, I keep going to the left by 5. Negative 2, negative 3, negative 4, negative 5, negative 6. Number 11, I have 1/3 times x minus 7 equals 1. 1/3 is no longer an integer, it is a fraction, but it is still a coefficient because it is right in front of that x and there's no operation sign there, so it is defaulted to multiplication. 1/3 times x minus 7, so I want to add 7, adding or subtracting away first. 1/3 times x left equals 1 plus 7 is 8. So I have 1/3 times x. I could divide by 1/3. It just looks a little funky when we have fractions. We don't usually then divide by a fraction. That just makes the look of the equation a little bit more complex. So in this case, I'm going to multiply by the reciprocal or multiply by the opposite. That is really the same thing as dividing, it just looks different. So I'm going to multiply by the opposite of 1/3, which is 3 over 1. That is called the reciprocal when I flip the numerator and denominator. 3 times 1 over 1 times 3. So what I just said was 3 times 1 over 1 times 3. That is 3 over 3, or just 1x. And 8 times 3 over 1, or 8 times 3, is 24. And the last one here, so for the last one here, x plus 7 is all on top, so we have these invisible set of parentheses here. I want to make sure that x plus 7 stays together for now. So the opposite of, well, let me back up. So there's no adding or subtracting away that we can do yet because the plus 7 is on the numerator, or in the numerator. It's on top of the 2, just like x is. So we cannot add or subtract away yet. So I need to move to multiplication or division. Right now I have dividing by 2, so I'll do the opposite of that, or multiply by 2. Multiply by 2. That cancels out those 2's, so I'm just left with x plus 7. I could keep it in parentheses, but now that I only have x plus 7, I don't need those parentheses anymore. And 2 times 2 is 4. Now I'm allowed to add or subtract away, because I have nothing else. I would need to get x completely by itself. X equals 4 minus 7. Those are opposite signs because it's 4. That minus is really the 7 goes to the 7. So we have a positive 4 and a minus or a negative 7. I need to treat those like subtraction. 3. But our answer is negative 3 because 7 has the greater absolute value and there's a negative or a minus sign in front of 7. And that's it. Comment below if you want to see any other types of two-step equations.